So good morning, everyone. Thank you very much for coming to today's CBCS seminar. So the seminar today is going to be presented by Dr. April Reside. So she's a lecturer in agroecology and wildlife science in the School of Agriculture and Food Sciences. And today she's going to be talking to us about cockatoos and climate change. And this is part of a grant called Climate Change Adaptation for Planning for Threatened Species. So this is part of a pilot project. So take it away.
How's the sound? Is that okay? Excellent. Thanks everyone for coming along. And thank you, Alice, for the introduction, and thanks for making it short, because there's nothing worse than standing through a long introduction in front of a group of people. This project came about through a collaboration with the ACT government, who are really ahead of most other jurisdictional governments I know in terms of their planning for species and biodiversity and getting in there with some climate change considerations as well. So they reached out to us and asked us to help them with this process. And so that, was a pretty amazing opportunity to really think this through for a few species. And when I say we, I mean Andrew did all this work, and I would have made Andrew give the talk today, but he conveniently had to go down to Melbourne. So unfortunately, Andrew's not here, so do save all your questions. He'll be online and can answer any questions that you may have about anything about the whole entire project. He also made many of the beautiful slides and figures that I'm going to present today. So I really enjoy taking credit for his really beautiful presentation. So thank you, Andrew, if you're online at all. Really appreciate it all. So the ACT government came to us and said, we'd really like you to tell us how we can build in considerations for two of our key species that we manage in the ACT to make sure that the management that we're doing is climate change adapted. Like, what do we do? How is it different from what we're doing now to make sure these species are going to be okay despite anything that comes their way due to climate change? And the two beautiful species, the gang cockatoo and the glossy black cockatoo. So the process that we went through to try to think this through was to think about, well, what will climate change actually mean for this area? What will it mean for the species' ecological needs, and how will it interact with their current threats? And then what are the kind of management levers, is what they use in government speak, to try and do our best to mitigate those impacts to these species. Beautiful cockatoo species. We've got the glossy black cockatoo in southeast Queensland. They're really hard to find. So if you do get to see them in this part of the world, it's awesome. They're easier to find when the rest of their habitat goes up in flames in a big mega fire, because they come to Tweed Forest and Mount Cootha and hang out. And in 2020, they were suddenly much easier to see, but I don't know about anyone else, but I haven't seen them really much since. And then the gang cockatoo, which we don't get here. So I just wanted to give, I guess, a tiny bit of context in the way that I've approached climate change adaptation and impacts and adaptation for biodiversity in the past. And that's through running these correlative models. We know where species occur, and we can make a correlation with the climate conditions that are also in the places where these species occur, come up with a climate niche and go, this is our envelope of suitable climate. Where is that likely to be in the future with different climate scenarios? And then you can do that, parallel it out for thousands of species, do all sorts of prioritization analysis to come up with, well, where do we need to make sure that we protect and manage for as many species as possible? And then we can think through what habitat will always remain suitable for species and build this into our prioritization analysis. So done that for a bunch of years, made lots of maps. And now the ACT government's come to us and said, yeah, but what do we actually do now today for this cockatoo or this cockatoo species? Tell us, what do we do? So it's a very different way of thinking through climate change impacts and adaptation and actions. And we went to the literature to say, oh, well, we'll find out how everyone else has done it. And actually didn't find much at all. And in fact, when we started looking into this a year ago, we found one example in Australia where people have implemented an action to save a species from extinction due to climate change, and that is the Western swamp tortoise. They had to translocate it because its distribution was just vanishing fast. Yeah, I don't know if there's been stuff that's come out since, but that's why I'm super interested to learn if there's other climate change, let's implement this action in this place now for this species to protect them against climate change, because last time I looked, there wasn't a whole lot. So interested to know what else is happening out there. So a backgrounder on the glossy black cockatoo, in case people aren't already familiar with it, it's a highly specialist feeder. Now, the Australian continent, birds are known for their generalization usually. We don't have that many specialists feeders in Australia. So you've kind of got a couple choices in Australia when you're a bird. You either eat anything that you come across, or you only eat one thing and you travel all over the place looking for it. They're broadly your two main strategies for terrestrial birds, at least. The glossy black cockatoo's chosen the latter strategy, only eat one thing and travel really long distances looking for that one thing. And that one thing is the cones of the she oak trees, casuarina and aloe casuarina. If I say casuarina, I mean, any of the species within those two genera. They big birds, they need hollows to nest in, so they need big hollows in order to fit in. They also need to drink water. They travel a lot. There's a bunch of subspecies. And just recently, this subspecies of the glossy black cockatoo has been listed as vulnerable under the EPBC Act. I believe Tanya Plibersek just made that announcement a couple of weeks ago that they accepted that nomination because their population has declined, their range is declining, they've got a small population size and lost a lot of habitat in the bushfires. And for context, that's sort of where the range is, that little black circle on the map, and that's where we are here. If there's anyone online that is a bit unfamiliar with the geography I'm referring to. The gang cockatoo doesn't occur around here. They occur a bit south of here, which is a real pity because they are quite awesome birds. So hopefully you'll get to see one day if you haven't already. They also need massive hollow trees in order to nest in. They're also quite dispersive, probably not as dispersive as the glossy black cockatoos, and they're known to do a little bit of elevational range shifting from summer to winter, and also been nominated under the EPBC Act, but this one is for endangered, and there's some evidence that their populations are declining fairly dramatically, and the fires are a big part of that story. And as I mentioned, they're big birds, they need big hollows, and anything really that needs tree hollows, particularly big tree hollows, is facing this same issue, which is this global decline of big old trees. And of course, in Australia, that's particularly problematic. We've lost a lot of the big old trees due to timber harvesting practices, clearing for agriculture, and then just senescence without recruitment. So the big old trees are falling over and we don't have the next generation of big trees to replace them. It can take hundreds of years to get that big and have a hollow that big for a cockatoo. So if you're not getting that recruitment, that's a long time to wait to breed. They're long-lived birds, but I don't reckon they're going to be living for 200 years until hollows become available. So big problem for anything that needs big hollows, and that's particularly problematic for the big cockatoos. Right, geographical context. Here we are. Here's Australia. That's approximately the glossy black cockatoo range. That's approximately the gang cockatoo range. That's approximately the distribution of the Australian Capital Territory, who wanted us to make a plan for these species across their ranges or within their jurisdiction. Kind of looked at that, and when I think about climate change adaptation planning, I think a little bit more across the whole species range, because what happens if this one little spot isn't going to be suitable for your species in the future? Maybe we would want to concentrate our management for that species in another place. So I went back to the ACT government and said, why don't we pick a nice little narrow range species in your area and do a climate change adaptation plan for those? And they've got a grassland earless dragon down there. They've got a few things. And they said, no, do the cockatoos. Okay, cockatoos it is. But I liked my idea of the narrow ranged species. And so Caitlin Rutherford came in and did a 6-month master's research project, and she used the same protocol but did it for this little orchid species. It is somewhat narrow range, but not just restricted to the ACT, and she worked with the people working on the orchid across New South Wales and the ACT. They loved it. It was such a success. They're already implementing the actions that she recommended, and we just submitted the paper yesterday. So best conservation research to implementation I've ever been involved in. And yeah, it's been really fantastic. So that's super exciting. The cockatoo one is a little bit more ongoing. Climate, oh, I thought I had a clicker. I don't need to stand right there. Okay, so how's climate change likely to manifest in this area? Thankfully, a lot of this work had already been done, and we could just digest that for the ACT government and for looking for these species. So rainfall, a bunch of changes are projected for rainfall in this region. Notably, it's not just the amount of rainfall, but the timing of rainfall can impact species, of course. So projection is that there will be decreasing rainfall in spring times, decreasing precipitation. So yes, it does snow in Canberra occasionally. That's going to happen less often, which just by the by is great for this little orchid. They hate the frost. So there's going to be less really cold overnight. The orchid loves it. So that's nice. Good happy news story. Interestingly, a lot of New South Wales might actually have an increase in rainfall. But of course, any of the rainfall projections need to be in the context that Australia has incredibly variable rainfall interannually. So one year it's super dry, next year it's kind of dry, the next year highest rainfall on record, a couple of years later, driest year on record. So incredibly variable rainfall. So a percentage change, a 10% change in rainfall, what does that even mean when rainfall can be so highly variable, particularly with the El Nino southern oscillation cycles? Yeah, increasing rainfall in autumn was another projection. Now, another really important factor to keep into consideration in this part of the world is your likelihood of a severe forest fire. There's this index, the Forest Fire Danger Index, that is built around wind speed, humidity, and temperature. Of course, it's missing, what else do you need for a fire? Wind speed, really dry, high winds, really dry, and hot temperatures. You need fuel. Bit hard to model on a global scale or whatever. So that's the thing that's missing, obviously. And what you tend to find is the fire will happen when you get all of these conditions lining up after a big drought period. So the ENSO cycle, really, really wet period, lots and lots and lots of vegetation growth, then it dries out and you have a tinderbox. Along comes this really severe forest fire danger conditions, and then you have what some people term catastrophic fires or mega fires, fires that burn really hot, really fast and just scorch a really large area. So this particular index here is the change in the number of days per year where the forest fire danger index exceeds 50, which is a severe fire. After some fires 10 or so years ago, they actually had to add an extra category to the index because the conditions got just so dramatic. And the ACT do have a bit of a history of really, really, really severe, scary fires. So it's something that they're well aware of and something that they need to take into consideration. Probably only, maybe half a day to a day on average extra than they already have of really severe fire weather. Of course, out there in the western part of New South Wales, that's where you get really great conditions for severe fire. But as Christina pointed out, you need fuel. There's not that much fuel because it's so arid out there. And that the forest fire danger index is likely to increase in spring, temperatures likely to get hotter, and minimum overnight temperatures likely to not get as low as well. Okay, then the ACT already have a bunch of plans that they use, and they wanted to bring this climate change adaptation into these frameworks that they already had. thankfully that was sort of their job. Our job was to focus on the cockatoos. Yeah, so there's a couple of different climate models available for the cockatoos. There's one that the New South Wales Regional Climate Modelling had already developed, and one that we developed when I was at JCU a bunch of years ago. And interestingly, according to the climate niche models, the ACT wasn't really that high habitat suitability now, and maybe in the future it would actually increase in habitat suitability. I don't really know how good those models are. I ran them, so I'm allowed to say that. But anyway, that's what the climate model says. In the future, the habitat suitability will increase for glossy black cockatoos. Good news for the ACT, I guess. And for the gang cockatoo, not a whole heap of change for the ACT. I mean, these are pretty broad correlative models. So there's something that might give us a bit of an indication, but maybe not really give us much detail. So this model suggests that the north of the ACT might decrease in habitat suitability for the gang cockatoo into the future. But again, yeah, not super informative, really. So that's the climate change, but what about the interaction with the species' ecological needs and their current threats? Okay, I need to keep the Zoom screen into consideration when I design these slides. So the glossy black cockatoo, it wants to have their seeds in the seed cones that are ready to eat every day of the year. They need to have a big enough patch of their casuarina, aloe casuarina, so that they can have a really good feed. And ideally, they're going to have their food and their nest sites pretty close by, because it's pretty annoying if you had to, you know, drive to Cairns every time you want lunch, right? You want to be able to just go to the fridge. So they want their tree hollows next to their food. The current threats for the glossy black cockatoo are habitat loss and degradation. Again, there's an optimal age of the trees that have the seeds. So you need to have recruitment of these stands of aloe casuarina always coming up to replace the old stands that are senescing. Predation in the nest hollows might be an issue. We're not really sure how much of an issue. Competition, again, the fewer the old trees that we have, the greater the competition for the remaining trees. Honeybees, the European honeybees, compete with the native species for trees. Some of the other cockatoos, like the sulphur-crested cockatoos, are in big numbers. They compete for the trees. There's the cytosine beak and feather disease. Not a lot of evidence that that's an impact for the glossies. So what we think really are the big issues are loss of their hollow trees, loss of their food stands, lack of recruitment of new food, and then competition for the hollows, and having the food and the hollows in good proximity. So what does climate change mean for our little conceptual model here? Fire, when it's big and extreme, probably not good for food or hollows. And then hot days could affect fledgling survival, possibly even adult survival, possibly nestling and breeding success in general. And then the changing rainfall patterns probably are going to exacerbate already limited food supply. This is just to show that it's actually kind of complicated. It's really hard to drill down and go, what's climate change going to really do? So Andrew did the hard work of breaking this all down, of every single ecological requirement, every single possible threat and climate change interactions. I won't bore you with the detail, only just that lots of thinking went into trying to get to the detail of what this might look like. And unfortunately, we don't have data on a lot of it. So what we had to do was to really focus on what people already knew about the cockatoos and what they could inform us, to focus on which are the threats and which are the interactions. And it's a recognized survey technique where you get people in the room or on Zoom if it's COVID, and you go through and have a big discussion and get everyone to make the estimates and then talk about those estimates and try and find out why people might disagree and who has knowledge from different parts of the range or in different contexts. It's something that we use all the time. There's some really good protocols around it, but I guess the thing with estimating climate change impact is experts know what they've seen and the data that they've collected, which has happened in the past. So they're going to be weighting their expertise and their opinions on what they've seen and what they understand. And that's more certain than what they're estimating for the future, which hasn't happened yet. So it can be really hard to get that thinking into the future. And because we don't know, the uncertainty is so great. Yeah, so the process, you compile the information, you go through it with the experts, you get their expert judgments on a bunch of things, and then you go through it together. We used this impact rating from this particular interaction on this particular threat. Would it cause very rapid declines all the way down to no declines, or we really don't know at all? So we got the experts to rank everything on what they believe the severity is most likely to be. And I've represented this in the thickness of the red arrows in the future figures. And then we also asked them to estimate the certainty. Now, we do certainty between 50 and 100, because if you're less than 50, then in theory, you're so unsure there's no better than a random chance that you know what you're talking about. And so certainty was sort of, as you can see there, somewhere between 60 to maybe 70%, because we're estimating the future. We're not really sure how things are going to work. Okay, so we looked at all of those big conceptual diagrams with all of those arrows going all over the place. These poor experts had to go through about 45 different. The impact of extreme fire on big hollow-bearing trees will have this impact on the near future and this impact on the far future with these certainties. They went through a whole ton of them, and fire just came up. Extreme fire. So of course, when I talk about extreme fire, I'm not talking about just ecological burning. Most of this continent burns at some point. It's part of the vegetation succession, and that's how it all works. But a big extreme fire is one that just flattens a really big area and is not ideal for the ecosystem. But the extreme fire is likely to have the most severe impacts for glossy blacks. That's their big hollow-bearing trees, their proximity of their breeding habitat to their foraging habitat, their food, the food that's available, patch size, and then also fledgling survival. So yeah, and we did discuss the fact that we were doing these workshops in 2021 and people were still so very much thinking about the big fires that happened in the 2019-2020 season. So it was so ever present. Did that create a biased view because of that proximity bias? Like, we just had this big event, everyone's thinking about it, dealing with the aftermath, dominated the discussion? Or does that actually reflect the reality that fire is something that really needs to be managed into the future and will be the biggest impact? For the gang cockatoos, interestingly, extreme temperature impact on breeding success was the first one. Fire also obviously super important, but habitat loss and degradation also coming out, super important. So yeah, sort of no surprise, big fire impacting food and tree hollows, and then the extreme temperature on breeding. And Andrew made these really stunning conceptual diagrams to make that story a little bit easier to understand. And you can see the near future arrows in the yellow and the far future arrows in the red. And you can see we're trying to show those, the climate change impacts, which are in the yellow part of the circle, impacting the food, the survival, and the breeding. And we didn't, yeah, the experts didn't think that the predation or the disease or even the competition were really the big issues here. It was all going to be fire and temperature impacting trees. And then similarly for the gang cockatoo, again, it was fire and heat impacting breeding and trees. So then we had to think through what are the management options. We'd planned to go down to the ACT and go and meet everybody and see the sites and everything, but COVID put a stop to that, unfortunately. So we had to rely on just hearing via Zoom the managers talk about what they do and what the options are. And the plan was to try and make sure our management recommendations were going to fit within the adaptive space and not maladaptive space. But yeah, it all becomes tricky to think through all these fantastic conceptual ideas that people have about managing climate change, and then think through a species and its tree hollows right now and actions we can take. So for the Gang cockatoo, our first goal was to increase their breeding success. And yes, this is what we're going to be facing for their tree hollow loss. What do you do in the face of these crazy big fires that threaten people's lives and homes and livelihoods? The poor old cockatoos' nest hollows aren't the top of the priority list when these big fires come along. And, you know, fire is just so incredibly political in its management, of course, because people's lives are at risk. So it's a really huge thing to try and address for threatened species. And the managers talked about, you know, what they're up against in trying to do that management. There's probably some things we can do. Christina gave some really good examples about protecting nest hollow trees manually, like getting in there and raking around. If you didn't see Christina's talk on palmies, you know, follow that up because it's super important. You know, these big hollow trees are in short supply. We need to protect them from these big fires, and raking around the base of them, possibly even putting something that protects the tree, some kind of physical barrier around the tree that can just protect it from some of the heat and flames. Interestingly, we learned that one of the threats to the big old trees is that they need to bulldoze a path to get to the fire front to fight it. And if the fire's there and there's some trees in the way, the trees have got to go. And so actually a lot of the trees get lost in that process, building the access to the fire. So the managers tell us that if we can get some really good priority maps, so these are the very high priority trees that you really shouldn't bulldoze, then they might be able to bulldoze around them when they get to the fire front. So that was pretty much the top of the list, is get the map of those priority trees, get them on the fire planning list so that when they're out there, there's a better chance that those trees won't just get knocked down. So it's, yeah, I do not envy the people that are having to do this planning and implementation, I'll tell you that. So gangs, the nesting trees, damage in wildfire, and then survival of nestlings in heat waves. I had this fantastic idea of solar paneled hollows where when the temperature hits a certain threshold, a little air conditioning unit comes on, maybe some fans, maybe a little bar fridge with some cold drinks, you know, but for some reason people seem to think that wasn't super feasible, but I just feel like they weren't really thinking it through. Anyway, so the objectives were maintain and improve breeding habitats and to increase the availability of nest hollows with high thermal buffering. Apparently that doesn't include little air conditioning units that are solar powered. What we need to do is get maps of the important breeding habitat and find a good design of the nest boxes, and to work out, will the gangs use the nest boxes? Obviously, if they're not going to use them, they're not going to be much use. And so the idea is that we need to keep the big old trees standing. We need to recruit big old trees. They're the big priorities, but perhaps the artificial nest hollows are a good stopgap, and maybe they can just be used for supplementation, perhaps straight after a big fire. They could be used as well. And they're used by the other big black cockatoos in other parts of Australia, particularly the Carnaby's cockatoo in southwest and Western Australia. They call them cockatubes, and they apparently get used all the time. They're deploying cockatubes for glossy black cockatoos in the southeastern parts of Victoria and the East Gippsland. I haven't heard much about the success. But they're enormous. These are a big bird, so those cockatubes must be enormous and quite a task to get up into the tree. There's a bit of work that's going on for making tree hollows with chainsaws. Now, I was really skeptical when I heard about this. I thought that's a terrible idea because that's going to damage the tree, and then people are going to stop caring about the big old natural hollows because we can just make some more. So I was super skeptical, but I hear that what happens when you use a chainsaw to make a hollow in a tree, the tree just like grows back over it straight away, and you actually need to not only carve the hollow, but then you need to put something physical in there to stop the tree just closing back around it. And the thermal buffering is phenomenal because it's not dead wood surrounding them, it's live wood. And of course, live wood has an amazing buffering effect. So yeah, perhaps chainsaw hollows could be the way to go. Maybe we can't make them big enough for our cockatoos, but possibly worth investigating. And so we need to think through where and how and what we would do if there was a big event where a whole bunch of trees got lost and we needed to get some nest boxes out there straight away to just make them available so that we didn't completely miss a breeding season. Would they take food if we left them out for them? We went and got some gang seeds and put trays on that. We have no idea. The managers were a bit skeptical about that idea, but maybe it's worth trying, particularly after a big fire event. And then the biggest barrier and challenge to this implementation is just the very political nature of fire management and how lower down the priority list to threatened species home is in these kind of scenarios. So that's a huge challenge. So yeah, things we want to implement straight away, things that we would implement if all of a sudden there was big impacts to the breeding habitat. And then the next one was making sure for the glossy black cockatoo that they had food where they need the food and in enough supply. So the food limitation is the big threat. I hear from the glossy black cockatoo experts that you'll have a stand of your beautiful aloe casuarina trees. They're all about the same age, they're all in the same plot, same soil type, it all looks great. They will forage on that tree and not that tree. And just the cones in one particular part of this tree and not the other part. So they're really fussy, and there's tons of work being done in this space. Daniela Teixeira is doing some really amazing work, and a bunch of people in Southeast Queensland and other parts of the range to figure it a bit out, to what exactly is it that they're looking for in those seeds? How do we manage their stands of habitat to give them what they want? Presumably they like the really high oil content in the seeds, the really highly nutritious seeds. Presumably better soil nutrients lead to better seeds, a bunch of hypotheses that we need to get to the bottom of. And then once we know what they're after and we can learn how to create that through restoration actions, then we can go and implement them. So some knowledge gaps that need to be filled, lots of exciting work happening in that now, and then also planning for succession. If we've got an age stand, certain age class in one stand, let's get planting in the right kind of sequence to make sure there'll always be food available. And another thing that we threw into the mix for climate change adaptation is that thinking through what the seed stock would be for what we'd plant. So in restoration works, historically, always the mantra was plant local. Local species and local individuals are the ones that are pre-adapted for those conditions. So if we always use the local seed stock, then we're using the plants most likely to thrive in that environment. Well, here comes climate change. Maybe those conditions aren't the ones that these species need to, or these individuals need to be adapted for. So why don't we hedge our bets? Why don't we get some seed stock from local and then some seed stock from somewhere that we think is going to be analogous to how the climate is going to be at our site in the future? Because of the uncertainty, and we're going to hedge our bets, let's get some seed stock from a bunch of different places that are hotter and drier or more variable. And hopefully some of those seeds are going to have the kind of adaptation to the conditions that climate change is going to bring. So that's what we call composite providencing, getting seed stock from a range of locations to try and find some pre-adapted to climate change. And so there's lots of great planting that's happening now, but we need to increase that if there does seem to be a little bit more loss of foraging quality. The barriers and challenges for this are the uncertainty of climate change, and then just who knows what they want. We don't know. We're trying to find out. So difficulty of understanding their nuances. So the things that we didn't quite to do would be the feasibility of the actions and the benefits of the actions. So we've got a bunch of ideas, you know, with the nest boxes and the plantings, but how feasible are they? Apparently my solar powered air conditioned little nest boxes with the bar fridge isn't feasible. We didn't test the feasibility, so that remains. What kind of trade-offs do we have? We implement this action and not that other action. What are we missing? The governments, of course, are super interested in the co-benefits. If we protect these trees from these fire events, who else is going to benefit? Because that makes their lives easier, more species benefiting for the one action. Climate smart restoration, something we need to think more about. Experts get really sick of you asking them millions of questions for days and days and days on end. And it's important to note that when you ask the same people the same questions, you get the same answers. And at some point we do need to go out there and collect some data, because they're only telling you what they know. Sometimes it's what they've seen or collected themselves. Sometimes they've all read the same paper. But until we actually get some good data of what's going on out there, we're just expert opinion can only get you so far. The ACT government wanted us to give them a process in which to decide that they would just abandon management. Just no, it's just not worth it anymore. This species is just going extinct in the ACT. We can't invest anymore. That's a really difficult and obviously quite a value-laden judgment to make about when you would stop investing. And I'd argue that if the species were declining in the ACT, but declining worse elsewhere, then maybe investing in their management in the ACT is still worthwhile. But again, that's a value judgment and not one that we really felt particularly qualified to make. Oh. Next time, face-to-face workshops I think would be awesome, and we would be able to involve the experts a little bit more in that end process, which we had to wrap up quite quickly. In conclusion, we need lots of big hollows for all the species that need them, in particular the cockatoos. So retaining and recruiting big hollow trees is absolutely top of the list for conservation importance. Food in proximity to those trees is also obviously super important, which means we need to retain and restore food habitats. And we also need to think about the restoration for climate change adaptation. Fire management. Fire is already crazy hard to manage, and it could get and likely to get a whole lot harder when the conditions that are going to result in more big catastrophic fires increase in frequency and severity. It's going to, what does that look like in the future, managing those kind of fires? And perhaps we need to think through the long-term actions, but also the short-term actions to get species through the bottlenecks. And maybe that's putting out supplementary food and lots of artificial hollows. We need to do better monitoring across Australia. We don't really know how many cockatoos we've got, how many individuals, and what's going to happen when we go out there and deploy our conservation interventions. Do we get more than we had before we did our conservation intervention? And has that got to do with our intervention, or just the fact that the conditions have fluctuated as they do? So I invite you all to join the Great Glossy Count, which I believe is going to be an annual event. Who did the Great Glossy Count this year? Anybody? Yeah, one person. They're really hard to find. There are so few of them, and they could be in such a huge area. So the only way to get a good survey is lots of sites counted. So it's one morning a year. It's super fun. Going out and just looking for glossy black cockatoos. And although it's somewhat unlikely that you'll definitely see a glossy black cockatoo, you'll see lots of other birds, and that's great. And they're around Brisbane, super close, Toohey Forest, Mount Cootha, little patches of bush all over the place, and they all need to be counted. So do join your local citizen science counts, because that's how we're going to get species monitored, particularly these big wide-ranging species. Thank you everyone for listening. Love to talk more about climate change management implementation. Any questions on the presentation? There's Andrew's contact. Feel free to ask Andrew any questions. If he's not online and hiding, which, you know, I would not blame him for, I'll give it a shot answering any questions in the meantime. So thank you very much.